What's up, everyone? Finishing out our presentation of data, this time with cumulative frequency graphs. So let's get into it. All right, so talking about cumulative frequency in general, before we talk about the graphs, the cumulative frequency is the accumulation or the sum of the frequencies leading up to and including that event. So for example, we have a very basic graph or table here where we have just random data values, 1, 2, 3, 4, and then how many of the things had those data values. So we had 1 that had the data value of 1, 3 that had 2, and we can figure out the rest. The cumulative frequency column, it will always start with whatever that first frequency is. That will be your cumulative frequency, the first cumulative frequency. But then from there, you'll take that number and you'll add it to the next line. So 1 plus the cumulative or the frequency of 3 gets me 4. And then I'll take 4 and add it to the next line. 4 plus 4 gets me 8. And 8 plus my final frequency of 2 gets me 10. So it not only just keeps adding up, which is easy enough, but it can also, that last number can also tell you the total number of frequencies since you were adding it along the way. If I add up 1, 3, 4, and 2 for my frequencies, I'll get that cumulative frequency, that final cumulative frequency of 10. A cumulative frequency graph takes those cumulative frequencies that you would have just found and obviously displays them. So how you graph this, or how we graphed this in this one, is if you see these 4 dots, those represent the cumulative frequencies we found. So the data value at 1 had a cumulative frequency of 1. Next, the data value of 2 had a cumulative frequency of 4. 3 had a cumulative frequency of 8. And 4 had a cumulative frequency of 10. So once you have those 4 points plotted, you're just connecting them with straight lines, always starting from 0, 0, or from the origin. So it will always be increasing the entire time because you kept increasing the accumulations. One other thing that's important before we get into an example with cumulative frequency graphs is to think about percentiles. Not percentages, but percentiles. So percentile is the score below which a certain percentage of the data lies. So for example, the 85th percentile is the score below which 85% of the data lies. Or if you score on a test in the 95th percentile, 95% of the class scored less than you. So basically, whatever that number is, it's the highest value in the percentage. So the 85th percentile, I'm at 85% and I'm including all the values below it. Or in the 95th percentile, I'm including all the data values below 95%. When it comes to our lower quartile, median, and upper quartile, our lower quartile, or Q1, is the 25th percentile. So when I look at Q1 down here, because my data information will be on the x-axis, remember, and then my cumulative frequency will be on the y-axis. So my lower quartile means that 25% of the data is within this part of the graph. My median, or for this graph, Q2, we don't usually use that, but that was in the graph, means that 50% of my data is within this part of my graph. So either to the left of that Q2 or below whatever the cumulative frequency is for that. And then my Q3, or my upper quartile, represents 75th percentile, or 75% of the data is below that value. And then obviously my 100th percentile is including all 100% of the data. All right, so let's get into an example. This cumulative frequency graph shows the amount spent by 70 customers at a clothing shop. So it's important to note that this graph, or this problem, tells us that it was from 70 customers. If for whatever reason the problem itself doesn't tell you that, you can always tell from a cumulative frequency graph how many total data values they're looking at. It's not necessarily just the top of the graph. Be careful. They try to trick you with that sometimes. you want to look to see where does this curve end, what that last data value is, and over to your y-axis. That's how many total data values you had. In this case, it is the top of the graph, but it's not always. So just make sure you look for the end of the graph and over to the y-axis for what it is. All right, so we're first asked to find the median. Remember, the median is representing the 50th percentile. So I'm going to find 50% of my total number of customers, which was 70, is 35. So half of 70 is 35. That's not my answer. That just gives me a starting point for on my y-axis, on my cumulative frequency. If I find 35, so right here, anything or up until that point and below it, that's representing my 50th percentile or my median. What they're always asking for these problems, though, is an answer from your x-axis. So what we'll have to do, and this is why this note was in here, is we'll have to draw a line from the y-axis, from whatever that value is on the y-axis, stopping on the curve, and then dropping it down to the x-axis. So anytime they're looking for a percentile or for one of the quartiles or the median, you'll start on your y-axis at whatever value it is, over to the curve and down. And that answer on the x-axis, in this case 25 euros, is our actual answer. All right, so let's look at it again for lower quartiles. So I'm looking at the 25th percentile. So 25% of 70, which is 17 and a half. So again, on my my y-axis, going to 17 and a half. So this is 15, so 17 and a half will be right in the middle. From 17 and a half over to my graph, and then dropping down to the x-axis. So important to note, clearly my lines are not straight here. You want your lines to be as straight as possible. If this were paper and pencil, you'd want to use a ruler or some other straight edge. Depending on what platform you're using virtually, you want to use, if they have that straight line tool, like in Pear Deck or in GoFormative, you want to use that straight line tool. I don't have either of those here, so I'm trying to make do with the best that I can. Also, keeping that in mind, we'll accept a range of values. So like with that last one I drew, obviously not clear, and it didn't land on one of the grid lines like the last one did. We would probably accept for this, say either 18 or 19, because it's pretty close to both, or even an 18 and a half. So you would want to pick one, whichever one it looks like yours is. But just to give you an idea of what we're accepting, we would accept anywhere between 18 and 19 here. With my upper quartiles, so 75th percentile, where I'm going to find first 75% of 70. I'll be looking at 52 and a half. So again, up my y-axis, 50, so 52 and a half will be here. As straight as I can over to my graph or my curve, and then straight down, or as straight as I can. It's also helpful to note that, like, if you can't draw a straight line, like mine is awful right now, keep an eye on where things were, right? 52 and a half, I knew was right between, in the middle of this grid line or in the middle of this block. So I tried to keep that final point right in the middle of it vertically. And then when I drop down, I note how close I am to this left grid line and tried to keep it at least as close as I could. So I'm more like over here in terms of my final line. So around, again, a range, probably closer to 31, but we would accept, I think, anywhere between 31 and 32 euros. You should only have one value here. Don't put a range. You should just have whichever one it looks like that's closest to you. I'm giving you a range so that you understand what we would accept as correct answers. For my IQR, I'm taking my upper quartile minus my lower quartile, or your upper quartile minus your lower quartile. So whatever you wrote in those last two answers, you're just subtracting them, big minus small. So in terms of a range, it can be anywhere from 12 euros to 14 euros, depending on what you wrote there. Finally, our 60th percentile, just kind of testing that you know what a percentile is here. It's the same thing we've been doing, right? It's just a little bit worded a little bit differently. So my 60th percentile, I'll find 60% of 70, which is 42. I'll again find 42 along my y-axis. It's 45, so maybe around here, a little bit lower than half. And then same deal, over and down. Oh my gosh. Trying to get back on track here. Maybe around here. Again, straight edges come in handy, or those straight lines come in handy. But we're looking maybe around 27. I think we would probably accept between like 27 and 28. So before we move on to our last two parts of this, just noting about those lines. There's very little work here, right? Because even then you don't have to write out 50% of 70 is this. I could be able to tell that from where you put your lines. So you would at the very minimum, or at the very least, need to put in, I'm marking up my graph all over the place here, need to put in a horizontal line where you looked on your y-axis so that I could indicate where you're going, and then dropping down and that vertical line on your x-axis that you were looking at. But drawing in those lines in general, it's not only going to help you really figure out where you're going, but it's going to help us as the graders to see your work. We can't be in your head while you're doing it, so be able to see where you were looking for each of those questions. All right, and wrapping up example 2, we still have the same graph. My bill was a mere 20 euros. What percentage of customers spent more than I did? So they're flipping the script on us a little bit here. Instead of giving us a percentile to find, they're giving us the amount of euros and asking me to find a percentage. So the number of euros they give me was 20. So now I'm starting on my x-axis, since they gave me euros. I'm starting on my x-axis at 20, and I'm just going backwards. So I'm going up to my graph and then over to the y value, which in this case happens to be 20. It's not always going to be 20. It's just a coincidence with this one. So I'm going up and over. Now, remember, that gives me the cumulative frequency. That's not the percentage at all. So in order to figure out what percentage of customers spent more than I did, I can do this two different ways. Number one, I can figure out that they're asking me about the people who spent more than me. So this many people spent more than I did. 70 minus 20, so that means 50 people spent more than me. If they're asking me for a percentage, though, I'll have to divide that by the total number of people and then times 100. So I'm looking at 71.4%. I could also, that's one way, option 2, I could figure out what this percentage is, what this percentile is really, because it's that percentage will be the percentile. So I can figure out 20 over 70 times 100, whatever that percentage is, and then just subtract that from 100, and it'll still give me the 71.4. Just really is a matter of, I think they're both probably just as much work. It's just a matter of which way you see it. Do you want to do the subtraction first, or do you want to do the subtraction second? It doesn't matter. With part C, final part, how many customers, so no longer a percentage, but how many customers spent between 30 euros and 45 euros. So again, they're giving us the amount of euros. So I'll start on my x-axis. I'll start at my 30 and go up. At least this one is on a grid line again too. Go up to my graph and then over to my y-axis. So my cumulative frequency at 30 was 50. And then at 45, again, on my grid line. So at least I know where that is. I don't have to be quite as careful with my line. But knowing that it stops right there and going across to my y-axis. Oh my gosh, as straight as I possibly can. So a little under half, I would say that's around, what, 65, maybe 67? So those are the cumulative frequencies at those specific points. To figure out how many customers spent between those two values, I'll just subtract 67 minus 50. Gets me about 17 customers. Again, we could have a range there depending on how straight your lines were. I think that's 67. We would accept 67 to 68 there. So this could be 17 or 18 customers. It's just a matter of getting those lines as straight as you can.